Welcome to the digital learning program of DCE for BSc 3rd Sem Physics as per Karnataka University syllabus. Dear students, I am B.S. Patil, Government First Aid College, Dharwad. Today I am going to explain principle, construction and working with the theory which is involved in the Helmholtz galvanometer. This is the Helmholtz galvanometer. So this instrument is invented by Hermann von Helmholtz. Basically, this Helmholtz galvanometer is an instrument used to measure the DC current in the circuit. It is the modified form of the tangent galvanometer. So it overcomes the difficulty in the tangent galvanometer where there is no formation of the uniform magnetic field over a considerable region. So this difficulty is overcome in the Helmholtz galvanometer, means it produces the magnetic field over a considerable region. This Helmholtz galvanometer works on the principle that uniform field over the region is obtained in such a way that the rate of increase of the magnetic field due to the one coil must be equal to the rate of decrease of the field due to other in the same direction. So it consists of two identical circular coils having the same radius and the same number of the turns. So these are placed coaxially at a distance equal to the radius of the either of the coil. So two coils, so these C1 and C2 are connected in series so that the current through them is in the same direction. So magnetic field along this common axis at a point midway between C1 and C2 is uniform. So field is uniform even at a point away, just away from this center, that is O. So because increase in the field due to the one, it is compensated by the field formed due to the other. So a permanent magnet, the permanent magnetic compass is pivoted on this brass cup in midway between them. So this compass consists of a magnetic needle perpendicular to that aluminum pointer is placed. Represent diagrammatically the construction of the Helmholtz galvanometer. So this is the coil C1 and another coil C2. So these are having the equal radius and these are placed coaxially at a separation equal to the radius of either coils. So at this center, that is at a distance a by 2 from any coil, so compass box is placed, so at the center. So graphically we can represent the field formed due to these two coils as like this. So this is the magnetic field pattern formed due to the coil C1, and so this is the magnetic field pattern formed due to the coil C2. So the resultant magnetic field pattern we can represent like this. So this is the resultant field due to the both the coils, say C1 and C2. So here the magnetic field is uniform over a considerable region. Okay, so at this position the magnetic needle is placed so that magnetic needle can rotate under the action of the field formed due to the both the coils and also the field, the horizontal component of the Earth's magnetic field BH. Okay, now let us see the working of this Helmholtz galvanometer. First what we have to do, we have to adjust these leveling screws so that the compass box of the Helmholtz galvanometer is leveled. So now the magnetic needle, inside the magnetic needle is free to rotate in this horizontal plane. To set these plane of the coils in the magnetic meridian, first we have to adjust the compass in such a way that the line joining the 90° and 90° comes in the plane of the coil, and then the coil as a whole is rotated till the pointer, that is aluminum pointer, reads 0, 0. So in this situation, the magnetic needle is in the plane of the coil. So in this situation what happens? The field formed due to these coils and the direction of the horizontal component of the magnetic field are perpendicular to each other. In this situation, the tangent law can be applied. When the current passes through the coils, magnetic needle gets deflected through an angle theta. The current can be reversed with the help of the commutator, that is the direction of the current through this coil. The direction of the current is reversed with the help of the commutator. So here these terminals are provided here to select the number of turns as 250 and 500. So in this way the deflection produced in the Helmholtz galvanometer when the current is passed. Okay, now let us see the theory involved in the Helmholtz galvanometer. We know that the rate of change of resultant field is constant, that is dB by dx is equal to constant. Here B can be written as mu naught Ni A square divided by 2 into A square plus x square raised to minus 3 by 2. On inserting the value of B in this differential form, we can write dB by dx on differentiating this B with respect to x, we can write this as mu naught Ni A square divided by 2 into minus 3 by 2 into A square plus x square raised to minus 5 by 2 into 2x. Okay. On simplification, we can write this as dB by dx is equal to minus 3 mu naught Ni A square divided by 2 into A square plus x square raised to minus 5 by 2 into x. Okay. Now we can differentiate once again, that is d square b by dx square is equal to minus 3 mu naught Ni A square divided by 2 into A square plus x square raised to minus 5 by 2 minus x into 5 by 2 A square plus x square raised to minus 7 by 2 into 2x. Okay. So on further simplification, we can write this as a minus 3 mu naught Ni A square divided by 2 into A square plus x square raised to minus 7 by 2 on rearranging the terms into A square plus x square minus 5x square into A square plus x square raised to minus 7 by 2. This is equal to minus 3 mu naught n I a square, and further simplification we can write this as a square plus x square raised to minus 7 by 2 into, we can simplify this as a square plus x square minus 5x square. Further simplification we can write this as d square b by dx square is equal to 3 mu naught n I a square divided by 2 into a square plus x square raised to 7 by 2 into a square minus 4x square. But we know that this d square b divided by dx square is equal to 0, because dv by dx is equal to constant. Therefore, a square minus 4x square is equal to 0, or we can write a square is equal to 4x square, or x can be written as a divided by 2. That is, rate of change of field is constant at x is equal to a by 2. This implies b is equal to mu naught ni a square divided by 2 into a square plus a square divided by 4 into 3 by 2. On further simplification, we can write this as mu naught ni a square divided by 2 into 5 root 5 divided by 8 into a cube. For 2 coils, on simplification we can write this b as b is equal to 8 mu naught ni divided by 5 root 5 a. So this is the magnetic field produced in the Helmholtz galvanometer when current I flows. When the coils of the Helmholtz galvanometer are in magnetic meridian, then this B is equal to BH tan theta according to the tangent law. So this theta is the deflection of the magnetic needle when the current flows, when the current I flows through it. Expression for the current as I is equal to 5 root 5 divided by 8 mu naught n into A into BH tan theta. Now we can write the expression for current as I is equal to 5 root 5 A into BH tan theta divided by 8 mu naught n. So this these A, BH and number of turns and mu naught are constants. Thus we can write this expression as I is equal to K into tan theta, where K is called the reduction factor of Helmholtz galvanometer. So we can also write this as I is directly proportional to tan theta. So this is the theory behind the Helmholtz galvanometer.